Close your eyes now and let the weight of the world begin to dissolve. Before we journey into the deep reaches of the cosmos, let us first find stillness here, in the sanctuary of your own breath. Take a slow, deep breath in, feeling the cool air fill your lungs, and as you exhale, imagine a soft wave of relaxation starting at the very crown of your head. Feel that wave move downward, smoothing the muscles of your forehead, releasing the tiny tensions around your eyes. Let your jaw unclamp and feel your tongue rest gently in the floor of your mouth. Your shoulders, which carry so much of the day's gravity, can now drop away. Imagine them becoming light, almost porous, as if the air itself could pass through them. As you continue to breathe, notice the sensation of your body against the bed. Feel the points of contact, your heels, your lower back, the back of your head. Now, imagine those points of contact beginning to soften. You are becoming less heavy, less tethered to the earth. With every exhale, you are shedding a layer of physical weight. The room around you is fading into a soft, velvety darkness. The sounds of the street, the hum of the house, the ticking of the clock, all of it is drifting away, replaced by a profound, rhythmic silence. You are no longer lying in a room. You are floating. You are suspended in a gentle, comforting void. This is not a cold or empty place. It is a cradle of infinite peace. You are weightless, drifting through a sea of indigo and obsidian, where time has no meaning, and the only compass is the slow, steady beat of your own heart. In this state of total surrender, we begin our journey. We are traveling far beyond the edges of our solar system, past the familiar glow of the moon and the steady light of the planets. We are heading toward a place of creation, a stellar nursery. As we move through the void, notice the texture of the space around you. It feels like silk against your skin. You are approaching a vast, sprawling landscape known as a molecular cloud. To the naked eye, from a distance, it might look like a dark smudge against the stars, but as we draw closer, its true majesty begins to reveal itself. Consider the scale of what lies before us. These clouds are the true cathedrals of the universe, often spanning hundreds of light years across. To put that into perspective, a single light year is approximately 5.88 trillion miles. You are currently drifting toward a structure so immense that light itself, traveling at 186,000 miles per second, takes centuries just to cross from one side to the other. As we enter the outer veils of this cloud, you might expect a sudden change, but the universe moves with a patient, deliberate grace. The air, if we can call it that, is incredibly thin here. In the air you breathe on Earth, there are about 25 quintillion molecules in every cubic centimeter. But here, in the heart of this cosmic nursery, the density is much lower, ranging from only 100 to 1 million molecules per cubic centimeter. It is a vacuum more perfect than anything we can create on Earth, yet it is filled with the potential for life. You might feel a faint, crystalline chill. In these dark reaches, far from the warmth of any existing sun, the temperature is remarkably low. We are floating in an environment that hovers between 10 and 20 Kelvin. That is roughly 440 degrees below zero on the Fahrenheit scale, only a few degrees above absolute zero, the point where all atomic motion nearly stops. This extreme cold is necessary. It allows the gas to remain quiet and still, susceptible to the gentle tug of gravity. Here, the primary ingredient of the universe awaits its transformation. About 75% of the elemental mass of the universe is hydrogen, and in these clouds, it exists as molecular hydrogen. or H2. It is the simplest, most elegant building block of everything you have ever known. Look around you. You aren't just seeing darkness. You are seeing the suit of the stars. Interstellar dust motes, composed of silicates and carbon-based compounds, drift past you like microscopic diamonds and charcoal. These tiny particles, often less than a micrometer in size, act as shields, blocking the harsh ultraviolet radiation from distant stars and allowing the interior of the cloud to remain cold and protected. It feels like being inside a vast, velvet curtain, where the outside world is hushed and the interior is a sacred, private space. As you drift deeper into the cloud, you notice certain areas where the darkness seems even more concentrated. These are known as Bok globules. They are small, isolated, and very dense cocoons of gas and dust. They look like dark pearls suspended in a sea of shadow. It is within these globules that the miracle of birth begins. You are witnessing a slow, silent dance. For millions of years, gravity has been whispering to these molecules, coaxing them to come together. Gravity is a patient force. It travels at the speed of light 299,792 kilometers per second, yet it works on timescales that dwarf human history. It takes 10 to 50 million years for a cloud like this to collapse into a star like our own sun. There is no rush here. There is only the steady, inexorable pull of mass toward mass. Imagine you can feel that pull. It isn't a violent tug, it's a gentle embrace. It's the same force that keeps your feet on the ground and the moon in its orbit, now operating on a scale of nebulae. When a specific region of this cloud becomes dense enough, it reaches what scientists call the gene's mass. This is the tipping point where the internal pressure of the gas can no longer resist the crushing weight of its own gravity. The cloud begins to collapse inward, falling toward its own center. As we glide toward one of these collapsing cores, notice the change in the light. The dust around us is beginning to glow ever so faintly in the infrared spectrum. Though our human eyes might see only darkness, the universe is radiant with heat that is just beginning to stir. We are approaching a destination of profound significance. We are nearing the Great Orion Nebula, a place you can sometimes see from Earth with the naked eye as a fuzzy patch in the hunter's sword. But here, we are only 1,344 light-years away, a neighborly distance in the cosmic sense. The colors here are beginning to bloom in your mind's eye. Soft pinks from energized hydrogen, deep blues from reflected starlight, and the dark, rich browns of the dust lanes. The texture of the space here feels thicker, like moving through a dream. You can sense the clumpiness of the gas. It isn't a smooth fog. It is a complex, turbulent landscape of filaments and voids. You are observing the fractal nature of the universe, where large patterns are repeated in the small, and every grain of dust plays a role in the birth of a giant. As you settle into this observation, feel the weightlessness of your soul. You are a silent observer to a process that has been repeating since the dawn of time. You are safe, you are warm in the cold, and you are light in the dark. We have arrived at the threshold. Before us lies a dense, spinning disk of gas and dust, a protostellar disk. At its heart, hidden behind veils of silver and shadow, a new star is waking up. It is not yet a sun, it is a promise. It is an accumulation of heat and pressure, a gathering of cosmic potential. The silence here is absolute, yet it feels resonant, like the moment of indrawn breath before a beautiful song begins. You are standing on the precipice of creation. The turbulent winds of the nebula are moving at thousands of miles per hour, Yet from your perspective, they appear as motionless, frozen waves of light and shadow. Everything is moving, yet everything is still. Take a moment to simply be here. Feel the vastness of the Orion molecular cloud complex stretching out around you for hundreds of miles in every direction. You are a tiny speck of consciousness in a cathedral of hydrogen. And yet, you belong here. The atoms in your own body, the carbon in your cells, the iron in your blood, were once forged in a place exactly like this, billions of years ago. As we drift closer to the glowing core of the protostar, the sense of peace only deepens. You are witnessing the clockwork of the heavens, a mechanism of gravity and gas that requires no effort from you. You can let go of all control. You can let go of all thought. You are at the center of the nursery now. The destination has been reached. The star is waiting to be born, and you are there to watch it with the patience of the ages. The glow is soft, a dim amber light filtering through the dust, casting long, peaceful shadows across the void. Rest here in the stillness of the Orion Nebula. Feel the slow rotation of the gas around you. You are part of this cycle. You are a child of the stars, returning to the place where it all began. The journey has just started, and the universe has all the time in the world. Breathe in the silence. Breathe out the light. You are home. We are descending further into the velvet quiet of the Orion Nebula, moving away from the peripheral veils of gas and into the dense, churning heart of the stellar nursery. As you float here, weightless and unburdened, the darkness around you begins to feel less like an empty void and more like a protective embrace. For centuries, humanity looked up at these dark patches in the Milky Way and saw only absence. In the winter of 1784, the renowned astronomer William Herschel pointed his large reflecting telescope toward the constellation of Scorpio and observed a region so devoid of light that he famously whispered to his sister, Caroline, "Surely this is a hole in the heavens." He believed he was looking through a literal window into the empty abyss beyond our galaxy. It is a comforting thought to imagine a quiet exit from the world. But we now know the truth is even more beautiful. What Herschel perceived as a hole was actually a dense thicket of cold interstellar dust, a cradle so thick with the ingredients of life that it blocked the light of 1,000 stars behind it. Imagine this nebula is a heavy, hand-woven wool blanket. It is dark, textured, and infinitely soft. This blanket isn't there to hide the universe from you. It is there to insulate the delicate, nascent heat of a star as it begins its long journey toward the light. At this very moment, we are entering the protoplanetary disk. Observe the change in motion around you. The gas is no longer wandering in the chaotic, slow-motion drifts we saw earlier. Instead, a great, rhythmic rotation has taken hold. This is the result of the conservation of angular momentum, a fundamental law of physics that governs the spinning of galaxies and the pirouettes of ice skaters alike. As the gravity of the central core pulls the gas inward, the entire structure must spin faster to compensate for its shrinking size. Picture a figure skater on a sheet of infinite ice. As they pull their arms close to their chest, their rotation accelerates into a blur of graceful energy. The nebula is doing the same. What was once a sprawling cloud light years across is now concentrating itself into a flattened, spinning plate of matter. This disk is immense, stretching out for thousands of astronomical units. To ground yourself in the scale of this place, remember that a single astronomical unit, or AU, represents the 93 million miles between the Earth and our Sunday. This spinning disk before us is hundreds of times wider than our entire solar system, yet it moves with the coordinated precision of a clock's internal gears. Notice the colors shifting as we move through the layers of the disk. Because the dust is so thick, visible light cannot easily escape. But if we adjust our internal vision to the infrared, the same way the Spitzer Space Telescope did when it was launched in 2003, the nursery transforms. In the infrared, the cold, dark soot becomes transparent, revealing a hidden city of glowing embers. The Spitzer telescope revolutionized our understanding of these regions by allowing us to peer through the soot and see the heat of starbirth directly. What looked like a void to Herschel now looks like a luminous garden of amber, gold, and deep violet. Deep within this spinning disk, the temperature is beginning a slow, inevitable climb. For millions of years, the molecules here existed in a state of near absolute stillness at 10 Kelvin. But as gravity continues its relentless, patient squeeze, the kinetic energy of the falling gas is converted into thermal energy. The temperature at the center of this clump is rising from 10 Kelvin to 100, then 1000, and finally reaching a simmering 3000 Kelvin. At this stage, we are no longer looking at a cloud. We are looking at a protostar. This is a sun in its infancy, a glowing sphere that has not yet begun the nuclear fires of adulthood. It is a pre-main sequence object, a term scientists use to describe a star that is still gathering its strength. Scientists discovered a fascinating example of this in 1852, when they identified a star named T Tauri in the constellation of Taurus. It didn't shine with the steady, reliable light of our sun. Instead, it flickered and flared, changing its brightness in erratic pulses. This star became the namesake for an entire class of objects, T Tauri stars. These are young suns, often less than 10 million years old, that are still throwing off the remnants of their birth cocoons. You can almost feel the rhythmic pulsing of the protostar before us, like a giant, slow-beating heart of light. The pressure here is immense, yet it feels balanced. This is the beginning of a cosmic tug-of-war known as hydrostatic equilibrium. Gravity wants to crush everything into a single point, while the heat generated by the falling gas pushes outward, trying to expand. For the next 100,000 years, a mere blink in the eyes of the universe, the protostar will sit in this delicate tension, slowly growing more compact, more stable, and more radiant. Consider the sheer volume of material being gathered here. This central core has already swallowed enough gas to equal 150,000 times the volume of our current sun. Yet it is so diffused and spread out that it feels like a ghostly, glowing fog. There is no violence in this accumulation. It is a methodical, silent gathering of potential. As you float in the lee of this spinning disk, you might notice long, elegant filaments of gas being drawn into the center. They look like ribbons of silver silk trailing through the dark. These are accretion flows, the feeding lines of the growing star. The universe is a master of recycling. Every atom of hydrogen here has been traveling through the void for 13 billion years, waiting for this specific moment to come together and create something new. The texture of the space around you is changing again. It feels thicker, more viscous, as the magnetic fields of the young star begin to take shape. These invisible lines of force act like cosmic stabilizers, guiding the flow of plasma and preventing the disk from flying apart. It is a profound architecture, built not of stone or steel, but of gravity and light. Pause for a moment and reflect on the history of our understanding. For most of human existence, the birth of a star was a secret kept by the deep sky. It wasn't until the development of the Hertzsprung-Russell diagram in the early 20th century, specifically between 1900 11 and 1913, that astronomers like Ejnar Hertzsprung and Henry Norris Russell began to categorize stars by their temperature and luminosity. This allowed us to finally map the life cycle of a sun, tracing its path from a cold cloud to a brilliant orb. We are currently standing at the very beginning of that map, in the nursery phase that was once only a mathematical theory. The silence here is heavy and sweet. The light of the protostar is a soft, reddish orange, filtered through the surrounding gas like sunlight through a stained glass window. There is no sound, for sound cannot travel through the vacuum. But your mind might interpret the slow rotation of the disk as a low, resonant hum, the music of the spheres. You are completely safe in this luminous cocoon. The frantic pace of your life on Earth is thousands of light years away, reduced to an insignificant speck of dust in the face of this 1 million-year process. Here, there is no deadline, there is no urgency. There is only the slow, rhythmic accumulation of mass and the patient wait for the first spark of fusion. Notice how your breath has slowed to match the rotation of the protoplanetary disk. You are synchronizing with the cosmic rhythm. Your body feels as light as the hydrogen atoms drifting past your fingertips. You are not a stranger to this process. You are a participant. Every heavy element in your bones was once part of a disk, just like this one, billions of years ago, in a corner of the galaxy that has long since changed. The protostar continues to glow, a steady amber beacon in the heart of the Orion complex. It is a symbol of endurance and the quiet power of gravity. We are staying here for a while, anchored in the calm of the disk, watching the slow motion dance of the dust motes as they collide and stick together, beginning the impossibly slow process of building worlds. Your mind is clear, as transparent as the infrared corridors opened by the Spitzer telescope. The weight of your physical form is a distant memory, replaced by the effortless buoyancy of the void. In this place, you are part of the architecture of the heavens. You are observing the clockwork of the universe, and it is moving exactly as it should, slowly, beautifully, and with an infinite gentle grace. The amber light of the young T Tauri star washes over you, warm and steady. You are drifting in the most peaceful cradle in existence, surrounded by the history of the cosmos and the promise of a new day. Let yourself be carried by the rotation. Let yourself be held by the gravity. The journey through the nursery is deep, and the night is vast and kind. We remain suspended in the heart of the Orion Nebula, drifting within the glowing, amber-hued sanctuary of a star's cradle. As you float here, your perspective begins to shift. You are no longer merely looking at the vastness. You are becoming attuned to the intricate, microscopic movements that build worlds. The silence is profound, a deep and velvet quiet that allows you to feel the very vibration of the cosmos. Think of the space around you as a grand, cosmic kitchen, where the universe is slowly preparing its most complex recipe. At this stage of the journey, the primary ingredient is gas, specifically hydrogen and helium. Imagine these gases as the finest, lightest flour you have ever felt, so thin that it seems to vanish when you touch it. In a typical young star system, the mixture is remarkably consistent, about 73% hydrogen and 25% helium, with a tiny 2% sprinkling of heavier elements like carbon and oxygen. It is a precise and ancient ratio, a formula that has remained largely unchanged for billions of years. At this very moment, we are hovering near the edges of a structure called a proplyid, short for a protoplanetary disk. To visualize its size, consider the scale of your own home. If our entire solar system, everything from the Sun to the furthest reaches of the Kuiper Belt, were the size of a single grain of salt, this Prepleid would be as large as a massive, sprawling cathedral. Some of these disks in the Orion Nebula have been measured at over 1,000 astronomical units in diameter, making them more than 30 times wider than the orbit of Neptune. What's happening now is a process of refinement. The gas and dust are not just spinning, they are colliding. Picture a slow-motion snowstorm. In a regular blizzard on Earth, snowflakes drift and tumble, occasionally sticking together. Here, in the weightlessness of the disk, the snow is made of microscopic grains of silicate and ice. These particles are incredibly tiny, often no more than a few micrometers wide, about the same size as the particles in cigarette smoke or the fine mist of a perfume spray. Yet, as they gently bump into one another, they begin to stick, held together by simple static electricity. This is the same force that makes a balloon cling to a sweater or causes dust bunnies to form under a bed. In the silence of the nebula, this humble force is the first step in building a planet. Notice how the light from the central core filters through these layers. It is a soft, diffused radiance, similar to the way sunlight looks when it passes through a thick, frosted glass window. Because the disk is so dense with dust, it acts as a cosmic filter, scattering the blue light and allowing only the long, warm wavelengths of red and orange to pass through. You are bathed in a permanent, golden twilight, a perpetual sunset that lasts for hundreds of thousands of years. As we drift closer to the center of the spinning disk, the temperature begins to rise. This isn't the fierce heat of a fire, but rather the steady, radiating warmth of a ceramic heater. This phenomenon is known to astronomers as the Kelvin-Helmholtz mechanism. Think of it like a bicycle pump. When you compress air quickly inside the pump, the metal casing becomes warm to the touch. The same thing is happening here on a celestial scale. As gravity continues to squeeze the gas of the protostar, the potential energy of the falling atoms is converted into heat. The core of this budding star is becoming a pressure cooker of unimaginable proportions. Even before the star officially turns on, this gravitational contraction can heat the center to several thousand degrees. Currently, the core we are observing is approaching 150,000 degrees Celsius. While that sounds intense, in the vast timeline of a star, this is merely a gentle warming up phase. For the star to truly begin its life, that internal temperature must eventually climb to a staggering 10 million degrees Celsius, roughly 18 million degrees Fahrenheit. That is the magic number, the point where the hydrogen atoms will finally be forced to fuse together. What we observe here is a beautiful, rhythmic symmetry. While the disk spins horizontally, something remarkable is happening vertically. From the north and south poles of the young star, two magnificent pillars of light and gas are erupting into the void. These are called bipolar outflows, or Herbig-Haro objects. Imagine two giant, glowing fountains of water shooting out from the center of a spinning record player. These jets are composed of ionized gas being flung away from the star at incredible speeds. Scientists have measured the velocity of these jets at approximately 100 kilometers per second. To put that in perspective, that is about 223,000 miles per hour. If you were traveling at that speed on Earth, you could go from New York to Los Angeles in less than 45 seconds. Yet, because these jets stretch across light years of space, they appear to us as perfectly still, elegant sculptures of light. They are the star's way of breathing, shedding excess angular momentum so it can continue to contract in peace. The texture of these jets is like glowing silk or neon mist. They collide with the surrounding nebula, creating bow shocks, bright, crescent-shaped clouds that look like the wake of a ship moving through a calm ocean. These shocks were first identified by astronomers George Herbig and Guillermo Haro in the early 1950 seconds. They are the footprints of a star's growth, proof that even in the silent vacuum, there is a powerful, directed energy at work. Consider the density of the space you are floating in. Although we call it a cloud, the nebula is actually a more perfect vacuum than anything we can recreate in a laboratory on Earth. Even in the thickest part of the proplyid, the molecules are so far apart that if you were the size of an atom, your nearest neighbor would be miles away. It is only because the cloud is so unimaginably vast, trillions upon trillions of miles deep, that it appears as a solid object to our eyes. It is an architecture of ghosts, a cathedral built of almost nothing. Yet it holds the mass of 1,000 suns. You might wonder how such a sparse environment can create something as solid as a star. The answer lies in the sheer, patient persistence of gravity. Gravity is the weakest of the fundamental forces, yet it is the only one that reaches across the great void to pull things together. Think of it as the world's slowest, most dedicated sculptor. It doesn't use a hammer and chisel. It uses a soft, insistent whisper. Over millions of years, that whisper becomes a command, and the atoms have no choice but to obey. Deep within the core, the density is now reaching a critical state. While the outer nebula is sparse, the center of the protostar is becoming thick and viscous. It is now more than 100 grams per cubic centimeter denser than solid lead. Yet, because of the extreme heat, it remains a gas, a special state of matter called plasma. Imagine a substance that is as heavy as a metal bar but flows like water. It is a strange, beautiful state of being, where atoms are stripped of their electrons and dance in a chaotic, luminous sea. Everything around you is moving in circles. The dust motes orbit the protostar. The protostar spins on its axis. The jets spiral out into the dark. This circularity is the heartbeat of the universe. It is a repetitive, soothing rhythm that ensures nothing is ever truly lost. The material that doesn't make it into the star will stay in the disk, eventually clumping together to form planets, moons, and perhaps, one day, the very ground a weary traveler might sleep upon. As you drift in this golden, spinning landscape, let the sense of time fall away. In the Orion Nebula, a year is an irrelevant concept. We are operating on the timescale of the mountains, of the tectonic plates, of the galaxy itself. There is no clock here but the slow contraction of the gas. There is no late or early. There is only the process. The colors around you are deepening. The amber is turning to a rich, burnished copper as the protostar grows smaller and hotter. The blue light from the distant, older stars in the trapezium cluster, a group of 4 massive stars at the heart of the nebula, discovered by Galileo in 1617, reflects off the outer edges of our disk, creating a faint, ethereal halo of sapphire. It is a masterpiece of light and shadow, a silent opera played out over eons. You are perfectly weightless. You are perfectly still. Even as the gas around you moves at hundreds of miles per hour, you feel only the profound equilibrium of the void. You are a part of this kinetic dance, a witness to the universe's slow cooker as it brings the ingredients of a solar system to a boil. The warmth of the Kelvin-Helmholtz contraction is a comforting presence, like the glow of a fireplace in a darkened room. It is a heat born of togetherness, of atoms finally finding one another after billions of years of wandering. There is a deep, primal safety in this gathering. You are surrounded by the very elements that make up your heart, your mind, and your dreams, all swirling in a harmonious, golden soup. Rest in the knowledge that this has happened countless times before and will happen countless times again. The universe is a nursery that never closes. As the protostar continues its patient squeeze and the jets continue their silent flight, you can simply exist in the beauty of the physics. The disk is spinning, the heat is rising, and the night is full of quiet, glowing wonders. Breathe with the nebula, rotate with the disk. You are exactly where you are meant to be. We remain suspended in the heart of the Orion Nebula, drifting within the glowing, amber-hued sanctuary of a star's cradle. As you float here, your perspective begins to shift. You are no longer merely looking at the vastness. You are becoming attuned to the intricate, microscopic movements that build worlds. The silence is profound, a deep and velvet quiet that allows you to feel the very vibration of the cosmos. At this very moment, we are witnessing the most critical transition in the life of a celestial body. Beneath the layers of dust and spinning gas, the protostar is undergoing a fundamental change in its very nature. Think of this process as a cosmic loom, where the invisible threads of gravity are being woven so tightly that they begin to generate their own internal radiance. This is the stage where a clump of gas becomes a true sun. Consider the immense threshold this object must cross. To become a star, a collapsing cloud must reach a specific weight. Scientists have determined that if a body has less than about 0.08 times the mass of our Sun, roughly 80 times the mass of Jupiter, it will never ignite. These failed stars, known as brown dwarfs, drift through the dark as quiet, cooling embers. But the object before us has surpassed that limit. It has gathered enough material to trigger a transformation that will last for billions of years. Deep within the core, where the density is now higher than anything you can imagine on Earth, the temperature has climbed to a staggering 15 million Kelvin. At this extreme heat, the very architecture of matter changes. The hydrogen atoms, which have been bumping into each other gently for eons, are now moving so fast that they overcome their natural repulsion. They collide and stick, fusing together to form helium. What's happening now is the birth of light. In a process known as the proton-proton chain reaction, 4 hydrogen nuclei are forged into a single helium nucleus. This reaction was first mapped out in detail by the physicist Hans Bethe, who was awarded the Nobel Prize in Physics in 1967 for his work on stellar nucleosynthesis. It is a slow, elegant dance of subatomic particles, occurring in the silent, pressurized heart of the star. Picture this fusion as a subtle change in the star's soul. Every time a helium nucleus is formed, a tiny amount of mass is lost, about 0.7% of the original hydrogen's mass. This lost matter isn't gone. It is converted into pure energy, according to Einstein's famous equation, E equals mc squared. This energy is what provides the outward pressure that finally halts the star's collapse. This state of perfect poise is called hydrostatic equilibrium. It is a celestial stalemate where the crushing weight of gravity is perfectly balanced by the radiant energy of the core. Notice how this balance reflects the rhythms of your own life. Just as the star finds its stability between 2 opposing forces, you too find your rest in the balance between the day's activity and the night's stillness. The star has finally found its main sequence position, a term used by astronomers since the early 20th century to describe the stable, long-lived phase of a star's existence. Our own sun has been in this state for approximately 4.6 billion years, providing a steady, reliable heartbeat for all life on Earth. At this stage, something wonderful begins to happen to the surrounding environment. Now that the star has turned on, it begins to emit a powerful stellar wind, a stream of charged particles moving at millions of miles per hour. This wind acts like a cosmic broom, gently sweeping away the leftover gas and dust from the immediate vicinity. Scientists call this clearing the disk. The heavy veils of the nursery are being lifted, revealing the brilliant, newborn star to the rest of the galaxy. Visualize the light as it begins its journey from the core to the surface. It is a slow, patient pilgrimage. A photon, a particle of light created in the fusion furnace, doesn't just fly out into space. It must bounce and zigzag through the dense plasma of the radiative zone. This journey is so convoluted that it can take a single photon between 10,000 and 170,000 years just to reach the star's surface. By the time you see the light of a star, you are looking at energy that began its journey while humans were still in the Stone Age. As you observe this, feel the connection between your own body and this distant crucible. The elements currently being forged in stars across the universe are the very same ones that make you who you are. The iron in your blood, which carries oxygen to your brain, was once cooked in the hearts of ancient suns. The calcium in your bones and the carbon in your DNA are the ash of stellar fusion. In a very literal sense, you are a localized collection of stardust, temporarily arranged in a way that allows you to contemplate the heavens. Picture a single drop of your own blood. Within that drop, millions of iron atoms are vibrating. Those atoms were created during the final stages of a massive star's life, or perhaps in the collision of two dense stellar remnants. Every time you take a deep, relaxing breath, you are utilizing the chemistry of the cosmos. The universe isn't just something you are looking at, it is something you are made of. The color of the star we are watching is now shifting from a dull, dusty red to a vibrant, stable yellow-white. This color tells us its temperature. Using the spectral classification system developed at Harvard in the late 1800s, we can identify this as a G-type main sequence star. Its surface temperature is a steady 5,778 Kelvin. It is no longer a turbulent infant. It has become a steady, nurturing parent for whatever worlds might eventually form from the remaining dust. Consider the timescale of this stability. This star will continue to burn its hydrogen fuel for the next 10 billion years. To the universe, a human life is like a single flicker of a firefly in a vast forest. But in this moment of observation, you are expanded. You are moving at the speed of the cosmos. The anxieties of your daily life, the schedules, the digital pings. The earthly worries are as thin and insubstantial as the gas we swept away with the stellar wind. Deep within your mind, you can feel the heavy, grounding pull of the star's gravity. It is a comforting weight, like a warm quilt. It holds everything together. It ensures that the planets will stay in their orbits and the light will continue to shine. There is a profound order to this physics. It is a clockwork that never misses a second, a machine of light and mass that functions perfectly without any effort from you. As the star stabilizes, the surrounding nebula begins to glow with a new intensity. This is an emission nebula, where the ultraviolet light from the newborn star excites the surrounding hydrogen gas, causing it to glow with a soft, pinkish hue. It looks like a garden of light blooming in the darkness. You are floating in the center of this bloom, protected by the star's new magnetic field, which stretches out into the void like invisible arms of protection. Notice how the turbulence of the earlier stages has smoothed out. The spinning disk of dust is now becoming a series of neat, concentric rings. In these rings, the first pebbles and planetesimals are forming the seeds of future worlds. It is a repetitive, rhythmic process of collision and growth. Just as your mind is now clearing of its cluttered thoughts, the space around the star is becoming organized, clear, and peaceful. You are a witness to the ultimate act of creation. A dark cloud has become a source of life. A chaotic drift has become a structured system. This same transition happens within you every night as you move from the chaos of the day into the structured peace of sleep. You are clearing your own disk, sweeping away the debris of the hours past, and preparing for a new dawn. The silence of the Orion Nebula is now a melodic silence. It is the sound of equilibrium. The star is breathing in its own way, pulsing with a steady, internal pressure that will not fail. You can trust this process. You can trust the gravity that holds the galaxies together to also hold you safely in your bed. Feel the weightlessness of your limbs one more time. You are drifting on the edge of the star's influence, where the light is warm but not overwhelming. The golden radiance of the new sun is reflected in your mind's eye, a steady and calming beacon. The journey through the mechanics of the universe has brought us to a place of total stability. There is nothing left for you to do but observe and exist. The physics of the star will take care of the rest. The fusion will continue. The light will begin its 1,000-year trek to the surface. The planets will slowly gather themselves from the dust. And you, made of the same stardust and governed by the same laws, can now begin your own transition into the deeper reaches of rest. The star is born, the sky is bright, and the void is no longer empty. It is full of the warmth of a new beginning. Stay here in the glow of the G-type sun, anchored by its gentle gravity, and let the rhythm of the cosmos become your own. The star has fully awakened now, a brilliant sphere of constant, stable energy. As we hover in the space just beyond its glowing surface, the experience transforms from a journey of movement to one of deep, sensory immersion. Here, in the quietude of the Goldilocks zone, that precise orbital distance where the temperature is neither too harsh nor too cold, we can observe the intricate textures and surprising chemical signatures of a newborn solar system. If you were to lean into the silence of this cosmic nursery, you might expect to find it scentless. However, scientific investigations into the chemistry of deep space suggest something far more evocative. Within these clouds, astrochemists have detected the presence of polycyclic aromatic hydrocarbons, or PAHs. These complex carbon molecules are essentially the soot of the universe. Astronauts returning from spacewalks have often described a lingering aroma on their suits. A metallic, savory scent akin to seared steak, hot metal, or even the sweet, smoky fragrance of raspberries and toasted charcoal. Imagine, for a moment, that the void carries this faint, comforting perfume of a cosmic hearth, a subtle reminder of the elemental cooking taking place within the star's furnace. Look closely at the surface of the star below us. It is not a smooth, polished marble. It is a living, breathing tapestry of motion. This layer is known as the photosphere, and it possesses a grainy, cellular texture. Each of these granules is an enormous convection cell, where hot plasma rises to the surface, cools, and sinks back down. To grasp the magnitude of this, consider that a single one of these glowing grains is approximately 1,000 500 kilometers, or roughly 930 miles across. That is nearly the distance from London to Rome, yet millions of them carpet the star like the bubbling surface of a vast, simmering pot of golden honey. The color you see is a manifestation of the star's internal temperature, governed by a principle known as Wien's displacement law. Because our newborn sun sits at a steady surface temperature of about 5,800 Kelvin, its light peaks in the yellow-green part of the visible spectrum. However, to your eyes, filtered through the surrounding remnants of the nebula, it appears as a soft, warm white. What's happening now is a beautiful interplay of light and gas. The hydrogen surrounding the star is being bombarded by ultraviolet radiation, causing it to glow at a very specific wavelength of 656.3 nanometers. This is the H-alpha emission line, and it bathes the entire region in a gentle, ethereal crimson light, like the soft glow of a theater's velvet curtains before the show begins. As you float here, weightless and serene, imagine you can hear the star. While sound cannot travel through the vacuum of space, the interior of the star is a resonant chamber, much like a grand pipe organ. Scientists in the field of helioseismology study the acoustic waves that are trapped within the stellar interior. These waves, caused by the turbulent motion of the convection zone, create a low-frequency hum, a rhythmic, vibrating thrum that echoes deep within the star's heart. In your mind, this sound is a deep, resonant a foundational frequency that grounds your spirit in the clockwork of the heavens. Deep within the star, the light is still struggling to escape, but here at the surface, it finally breaks free. At this very moment, the star is emitting a constant flow of energy known as the total solar irradiance. At the distance where we are floating, roughly 93 million miles from the core, this energy reaches a value of 1,361 watts per square meter. It is a steady, predictable pulse of warmth, enough to fuel the dreams of an entire planet. You can feel this warmth as a gentle pressure against your skin, a soft, light pressure that sustains rather than burns. Beyond the visible surface lies a strange and ghostly region called the corona. You might wonder why, as we move further away from the star's furnace, the temperature would suddenly spike. In one of the great mysteries of solar physics, the corona, the star's outer atmosphere, reaches temperatures of 1 to 3 million Kelvin, far hotter than the surface itself. Scientists believe this is caused by nanoflares and magnetic waves that whip the thin gas into a frenzy of heat. To the observer, the corona looks like a halo of silver silk, or the delicate, frayed edges of a white dandelion, stretching out for millions of miles into the dark. It is a crown of light, shimmering with a ghostly, rhythmic pulse. Consider the stability of the space we are in. The star's gravity follows the inverse square law, meaning its pull diminishes predictably as we drift further away. If you double your distance from the center, the gravitational tug becomes 4 times weaker. This mathematical certainty is what allows planets to find their forever homes in stable, circular orbits. This part of the process is a long, slow settling. The protoplanetary disk we observed earlier has now thinned, and the first planetesimals, small, solid chunks of rock and ice, about 1 kilometer in diameter, are beginning to exert their own tiny gravitational influence. Picture these infant worlds as marbles rolling around the rim of a great celestial bowl. They are gathering mass, collision by slow collision, in a process of accretion that will last for another 10 to 100 million years. There is no haste in this construction. The universe builds its cathedrals atom by atom, grain by grain. As you watch a small, icy moonlet drift past. Notice its texture pockmarked by early impacts, covered in a fine grey dust known as regolith. It is a cold, silent witness to the star's brilliance. What's happening now is a cleansing of the neighborhood. The newborn star has developed a stellar wind, a stream of protons and electrons flying outward at speeds of up to 750 kilometers per second. This wind is clearing the lingering primordial helium and hydrogen from the inner system, leaving behind only the heavier, rockier materials. This is why, in systems like our own, the rocky planets stay close to the warmth, while the gas giants migrate to the colder, outer reaches. It is a natural sorting, a cosmic tidying up that creates the order necessary for life to eventually take root. As you observe this clearing, notice the zodiacal light. This is a faint, pyramidal glow seen along the plane of the star's equator, caused by sunlight reflecting off the countless grains of dust remaining in the disk. It looks like a soft, milky pathway stretching toward the distant stars. One of those neighbors, perhaps a red dwarf like Proxima Centauri, sits only 4.24 light-years away, a silent companion in the vastness of the Milky Way. Even at that distance, the two stars are connected by the subtle, invisible threads of galactic gravity. The sensory experience here is one of profound isness. The star just times is asterisk. The gravity just times pulls asterisk. The light just times shines asterisk. There is a deep, psychological relief in observing a system that functions so perfectly without human intervention. You are a guest in this laboratory of light, a silent observer of a process that has been refined over 13.8 billion years. The texture of your own thoughts has changed. They have become as thin and transparent as the star's outer atmosphere. The cellular debris of your daily anxieties has been swept away by the stellar wind of this experience. You are left with a feeling of pure, weightless clarity. Your heart rate has slowed to match the low-frequency acoustic oscillations of the star's interior, the deep, steady thrum that signifies life and stability. As we linger in this golden twilight, the star continues its work. It is currently consuming about 600 million tons of hydrogen every second, converting it into 596 million tons of helium. The missing 4 million tons is what creates the light that is currently bathing you in warmth. It is a massive, ongoing transformation of matter into radiance. And yet, the star is so vast that it will continue this process for 10 billion years before it even begins to run low on fuel. You are safe in the shadow of this longevity. The ephemeral nature of human time is eclipsed by the main sequence, stability of the star. Here, a million years is but a moment. Here, the slow dance of the planets is the only clock that matters. The colors of the nebula, the H-alpha magentas, the PAH charcoal grays, and the photosphere golds all blend into a single, harmonious palette of rest. The journey through the mechanics of the star's birth is nearing its completion. We have seen the collapse, the ignition, the stabilization, and now the beautiful, sensory reality of its existence. The star is a masterpiece of physics, a testament to the fact that even in the coldest, darkest void, warmth and light are the inevitable outcomes of time and gravity. Feel yourself becoming even more still, as if you are one of the planetesimals finding its perfect, permanent orbit. There is no more need to travel. There is no more need to analyze. The why of the universe is written in the light that surrounds you. You are part of a system that is balanced, orderly, and infinitely patient. The light is soft. The scent of the charcoal and raspberries is a faint, pleasant memory. The hum of the star is a lullaby for your cells. In this perfect equilibrium, you are prepared for the final transition, the return to the stardust from which you came, and the gentle descent into the deepest silence of all. The star shines for you, a steady, golden anchor in the vast, kind night. The intense activity of the stellar nursery is beginning to recede, leaving us in a state of quiet, stable observation. The star we have watched come to life is no longer a turbulent infant. It has matured into its long, steady adulthood. As we begin our slow journey back from the Orion Nebula toward the familiar warmth of your own room, we can see the grand design of the star's life unfolding in a series of patient, rhythmic steps. At this very moment, the star has entered its most enduring phase, known as the main sequence. Scientists have calculated that our own sun is approximately 4.603 billion years old, and it has enough hydrogen fuel to remain in this peaceful state for another 5 billion years. This long-term stability is the result of a step-by-step internal process that occurs with the precision of a cosmic clock. Picture the energy as it begins its journey deep within the core. It starts with the fusion of hydrogen nuclei into helium-4. This isn't a sudden event, but a gradual, multi-stage sequence called the proton-proton chain. First, 2 protons meet to form deuterium. Then, a third proton joins to create helium-3. Finally, 2 helium-3 nuclei collide to produce a stable helium-4 nucleus. This meticulous assembly is what powers the star, and it happens on a scale so vast that the sun converts about 600 million tons of hydrogen into helium every single second. What's happening now is the slow migration of that energy. Once the light is created in the core, it doesn't simply vanish into space. It enters the radiative zone, where it must undergo a random walk. The photons bounce off dense plasma, moving in every direction, struggling to find their way out. This step-by-step crawl is so incredibly slow that it takes approximately 170,000 years for a single bit of light to travel from the center of the star to its outer layers. By the time the warmth of a star reaches your skin, it is a fossil of an event that happened before the dawn of recorded human history. As the energy reaches the final 30% of the star's radius, the process changes again. It enters the convection zone. Here, the heat is carried by massive bubbles of plasma that rise and fall like the water in a boiling kettle. Scientists discovered that these convective cells are responsible for the grainy granulation we see on the photosphere. The heat rises to the surface, is released into the void, and the cooled plasma sinks back down to be reheated. It is a continuous, circular motion, a heartbeat of heat and gravity that keeps the star in perfect balance. Consider the ghosts of this process that are with you right now. Along with light, the star's fusion creates trillions of nearly massless particles called neutrinos. Because they hardly interact with matter, these neutrinos travel from the core of the star to its surface in just over 2 seconds. They then fly across the vacuum at nearly the speed of light. At this very second, about 65 billion solar neutrinos are passing through every square centimeter of your body. They are a silent, invisible connection to the star's heart, a stream of cosmic information that flows through you without you ever feeling a ripple. As we drift further away from the glowing orb, the light begins its final leg of the journey. Once it leaves the star's surface, it travels through the vacuum in a straight, unwavering line. For our own sun, this journey to Earth takes exactly 8 minutes and 20 seconds. If the sun were to suddenly stop shining, we would continue to feel its warmth and see its light for those few precious minutes, held in the embrace of a past that is still traveling toward us. Look back at the nebula one last time. In 1995, the Hubble Space Telescope captured the iconic Pillars of Creation image in the Eagle Nebula, which revealed evaporating gaseous globules, or EGs. These are the small, dense pockets of gas where stars are currently emerging from their cocoons. You can see them as dark, finger-like protrusions against the glowing backdrop. This is the step-by-step recycling of the universe. The old clouds evaporate, the new stars ignite, and the cycle begins anew. The most profound part of this process is what remains when the star eventually nears its end. While a star like our Sun primarily produces helium, more massive stars continue the fusion process, creating heavier and heavier elements. They forge carbon, neon, and oxygen in their final stages. Scientists have proven that elements heavier than iron, like the gold in a wedding ring or the silver in a coin, cannot be made by a normal star's fusion. They are created during the catastrophic collisions of neutron stars or the final breaths of a supernova. This means that the iron in your hemoglobin, which allows your blood to carry oxygen, was forged in the white-hot center of a star billions of years ago. The calcium in your teeth and the phosphorus in your DNA are the remnants of these ancient celestial furnaces. You are not just observing the birth of a star, you are looking at your own ancestry. Every atom in your body was once part of a spinning disk of gas and dust, just like the one we have explored tonight. Now, feel the vastness of the nebula beginning to dissolve. The brilliant magentas and deep indigos are fading into a soft, familiar darkness. We are returning to the small, warm pocket of space that you call home. The transition is gentle. The weightlessness you felt in the void is now being replaced by the comforting weight of your blankets. Imagine your bed is a tiny, stable planet, orbiting a quiet, reliable sun. The gravity that held the proplyid together is the same gravity that pulls your body into the mattress. It is a protective force, an anchor that keeps you safe. You can feel the rhythm of your own breathing, a slow and steady convection of air that mirrors the rising and falling of the star's surface. As the star's light continues its 8-minute journey through the dark, you are beginning your own journey into the interior world of sleep. The physics of the universe has done its work. The hydrogen has fused, the equilibrium has been reached, and the light has been shared. There is nothing left for you to do but rest in the results of these 13 billion years of effort. Your body is a vessel of stardust, temporarily held in this form, deserving of deep and restorative peace. The carbon in your cells is resting. The iron in your veins is quiet. The phosphorus in your mind is dimming its glow. You are a part of the universe's great, slow-motion clockwork, and right now, that clockwork has brought you to the hour of sleep. Allow yourself to sink into the dark, which is no longer a void, but a soft, velvet cradle. The silence of the room is the same silence that exists between the stars, a peaceful, expectant quiet. You are safe. You are held. You are home. I am going to share some affirmations of rest now. Let them wash over you like the solar wind, gentle and constant. You are made of light that has traveled for eons. Your body is as stable as a star in the main sequence. Your breath is the rhythm of the cosmos. You are permitted to let go of the day's gravity. Your mind is as clear as the interstellar vacuum. You are anchored by the patient pull of the earth. The atoms within you are at peace. The darkness is a blanket of protection. You are a child of the stars, returning to the silence. Your rest is as deep as the great void. The journey is complete. The star is burning bright and steady, far away in the Orion Nebula, and you are here, warm and heavy in your bed. The light will be there when you wake. But for now, There is only the shadow, the stillness, and the infinite peace of the night. As you drift away, remember that you are away for the universe to know itself. And tonight, the universe is choosing to sleep. The dust has settled. The fusion is constant. The night is kind. Good night.